Here we are asked to determine the hybridization for each interior atom of this structure that's seen here. Now, when it comes down to organic molecules, and you'll learn that organic molecules are anything that has a carbon in it, a lot of times you'll see shorthand notation or shorthand structures. This is a type of shorthand. What you need to be cognizant of is that we will always have all these carbon chains. So when you see a structure that looks like this, and you see an H bonded with something, as it kind of shows here, that H isn't triple bonding to the carbon. You're basically being told that this first carbon here is going to be attached to a hydrogen and whatever's next to it. So the first carbon will have a hydrogen attached to it, and then it'll have a triple bond with another carbon. Now the reason we have it in this order is because, well, hydrogen can only attach to one thing. So if you see CH, well, that H won't be in the interior of the structure because hydrogen can only attach to one thing, and if you're reading from left to right, it's going to attach to that carbon. So we've taken care of that first carbon, the hydrogen, and the triple bond. This next carbon, which had the triple bond, has a single bond to carbon, and this last carbon has 3 bromines attached to it. 1, 2, 3. So these are my this is essentially just a more expanded version of my structure here. And the interior atoms I'm looking at, I'm going to label as 1, 2, and 3. Now, whenever we're looking at hybridization, the key here is to determine the number of electron domains. All we want to figure out is, for some element or for some atom in question, how many electron domains do we have? So it's kind of as if, it's like a precursor to determining what kind of molecular domain geometries you're working with, because the number of domains will tell you what kind of orbitals you're using or what kind of hybridization that you're working with. So for my first carbon, so carbon number 1, I have 2 electron domains. I have a single bond with my hydrogen atom and then a triple bond with my carbon. That triple bond is one domain. It's a one central location where 6 electrons are going to be residing. And with having 2 electron domains, my hybridization will be an SP or an S1P1. And the trick that I tell students all the time is, if you want to determine what your hybridization is, add up the superscript values, and that will tell you your electron domain value. So since I have an electron domain of 2, my superscripts on S and P should add up to 2. Well, S can only go up to 1, and P can only go up to 3. Now, whenever you see a triple bond, that should tell you immediately that you have an sp orbital somewhere. Okay? So there is one little trick to this, is that if you do see a triple bond anywhere, you are going to be, at least a majority of the time, you'll be looking at an sp hybridization. If I could spell hybridization. Now, I don't want to say if you see a double bond, you will be sp2, because if you have 2 double bonds, well, that will also be an sp hybridization. But one guarantee is going to be that if you see a triple bond, chances are very good, so it's not really guaranteed, but still, if you see a triple bond, an sp hybrid orbital will be in play. If I look at my C2, my carbon 2, again, that carbon 2 has that triple bond to it. And I have 2 domains. I have the triple bond domain, and I have that single bond domain with the other carbon. So again, I have my sp orbital. It's the 3rd carbon that I need to take a look at. And I have 4 electron domains associated with that last carbon. So I have my S1, and then P goes up to 3. So sp3 is going to be 1 plus 3 is 4. So there you go. So if I have 4 domains with bonds, that is going to be an sp3 hybridization. Or if you have 4 domains in general. However, you always want to pay attention to whether or not something is expandable. Because if you have something that's expandable, you would have to pay attention to d orbitals in play. So everything in here that's a central atom, it cannot expand. It's carbon. It's in the 2nd row. So I can never go beyond sp3 as my maximum hybridization. So the quick tip for this is just paying attention to how many electron domains you're working with. And if you add up the superscripts on your S and P notation, that should add up to your number of electron domains.